Alright, welcome to Super Easy Physics and Mathematics. We're going to be looking at the part 2 of the solution to IGCSE Physics Paper 2 Extended Variant 2 May-June 2024 examination series. So this part 2 we're going to be looking at question 21 to 40. So part 1 has already handled question 1 to 20. So let's go in and look at the question quickly. Very good. So question 20 is on image formed by convex lens. So the ray diagram shows the formation of image by two different converging lenses. So this one here, which form the image on the same side as the object, and then this one form this is the object, and then the image on the opposite side. So if you look at this is the object and this is the image, and then based on the arrow, this is the object and then this is the image. So what is the point? The basic principle: ray parallel to the principal axis, after refraction through the lens, passes through the focus. So here is the focus, and then here also is the focus, and then a ray that passes through the optical center C is unrefracted. But if you look at the right hand side, this one is getting wider, so you trace it back, and then these ones are imaginary rays, and then they intersect at this point to form the image that is larger than the object. So this is what enlarged and visual image that is erect. So for this other one here, the image is visual, so it's on the same side as the object. Then the image is real and inverted. So here the image is visual, it is erect, and then it is enlarged. So let's look at, so image 1 is visual, so we have between C and D. Then image 2 is real, so the correct answer is C. So let's look at question number 21. White light enters glass prism. Now if you look at this diagram, this is a wrong diagram. Now for the ray to pass through this, is supposed to, the refraction supposed to start from here. Okay, supposed to start from here, then come to this point, and then from there it will be refracted this way like this. So this diagram is wrong, then this diagram is correct. So this is the correct diagram, and then which ray will be on the top? The top is going to be red and the bottom is going to be violet. So, and then if you remember, the spectrum is, you have the acronym you can use is Roig-Beef. So ray 2, which diagram describe what happened? Is diagram 2. So we are looking at between C and D. So which one is red on top? So the answer is C. Alright, so let's go to question 23. Please subscribe, like, share, and comment. That's the way you can support what I'm doing here. Okay, so the thermal radiation is part of the electromagnetic spectrum. So if I tell students, easy way to remember is radio, microwave, infrared, visible spectrum, ultraviolet, X-ray, then gamma ray. So the ray frequency increases in this direction. So if you look at them, which of them has the radiation, thermal radiation? Thermal radiation is the infrared, so which is this. Okay. Now, a remote control vehicle is traveling on the surface of a planet. The vehicle senses an obstacle ahead and it sends a radio message to the control room. So if we have this, so we can do a sketch of this. So we have the planet. So here is the planet. So on the planet you have the control room, then you have the, okay, so this is the vehicle in space. So okay, so he sent a signal to the control room here, and then the signals come, and what do we have? So the signal he sent come to the control room, and then the reply is sent back. So if you look at this, so it traveled D and it traveled D. So total distance is, so if you want to calculate the speed, is going to be 2D divided by the time. So if you look at that, what is the distance of the control room? So that is the velocity is equal to 2 times 2.4 times 10 raised to power 6 kilometers. So convert to meter, that is 6 raised to power 9 meter. That is times 1000. Then divided by the speed, radio wave. Where's the question here? Okay. Radio wave means that it's an electromagnetic spectrum. An electromagnetic spectrum travel with the speed of light, which is, okay, so this is the only thing you need to remember here. So times 3 times 10 raised to power 8 meter per second. So if you divide that, you're going to give us 16 seconds. So the answer is D. Which statement about the direction of magnet at a point is correct? Is the direction of a north pole placed at that point. So if, alright, can actually draw, okay, so let me just make a sketch of that. If you have a bar magnet, okay, then we have this bar magnet. So this is the north, and then this is the south. So if we draw the magnetic field line, and then you come to this point. So north pole exit, south pole enters, and then north pole exit. So what is the direction? We are looking at the direction of the magnetic field at a point. What is the direction at this point here? X. So the direction at this point is when you put your compass at this point. So if you put your compass here, and then the direction of the north pole of the compass, so you have north and south, where you point to, that will tell you the direction. So the direction of the force on the north pole placed at that point, so that gives the direction. So the answer is A. That is question 20. Question 25 is A. Now let's go to question 26. Okay, A student draw graph of AC supply and a DC supply. So which row give the correct label of W, S and Y? Okay, this X will give you the voltage of the DC is constant. Then W will give you the voltage of AC circuit. And then, okay, W is going to give us the voltage as a function of time. So we have voltage as a function of time. So, and it's sinusoidal. So that is Y. So Y is going to give you the label. So we have voltage, and then Y is AC, and X is DC. So the correct answer is D. Okay. Please subscribe, like, and share the video, and make your comments. Alright. A resistor transfer 100 joule of energy when a charge of 10 coulomb flow through it. What is the potential difference across the resistor? So we are trying to look at the potential difference. So if you look at that, we know the formula for the energy is equal to V multiplied by Q. So we want to find the potential difference. The potential difference, make V sort of formula. V is equal to the energy divided by the charge supply. So V is equal to 100 joule divided by 10 coulomb. So that will give us 10 volts. So the question here, are trying to confuse you whether it's watt or volt. So it's a test of the unit. So the power is measured in watts, while potential difference is measured in volt. Okay, wire X and Y are made from the same metal. So they are made from the same metal, so the resistivity is the same. And then if you want to calculate, you know that the resistance is equal to the resistivity multiplied by the length divided by the cross-sectional area. So if you look at that, so we can use wire S to find the resistivity. So what is the resistivity? Resistivity is equal to RA over L. So which is the same thing as 2 times 0.4 divided by 1. So this will give us 0.8 ohm cm. Okay, ohm millimeter. Okay, ohm millimeter. Then so we can now use this to calculate for the resistance here. So arrow for wire Y, arrow Y is equal to rho L over AY. So which is the same thing as 0.8 times 1.3 divided by 0.30. So this will give us the value here is going to give 3.747 ohm. 3.47 ohm. So 3.47, that is approximately 3.5. So the answer is D. Very good. Now potential divider. The reading of this potential divider, this is 1.8 volts. And then mind you, the total voltage is 3 volts. So if that is 1.8 volts, so the across this upper resistor is going to be 1.2 volts. So add these two together will give you 3 volts. So now the current that is flowing through them is the same. So mind you, so I is equal to the current here, which is 1.2 volts divided by 5 kilo ohm is equal to 1.8 volts divided by R. So make R so the formula. So R is going to give us 7.5 kilo ohm. So the answer is C. Okay. Now, 2 electrical appliances are connected to the main supply. The cable connected to one appliance include an earth wire for grounding. The cable connected to the second appliance does not need an earth wire. What is the reason for this difference? Okay, that is question 30. The correct answer here is A. The appliance has a metal case, but the other appliances, that is this one does not have a metal case. Okay, so this one is insulator. The case is made up of insulator, while this one has a metal case. Okay, and when that happens, what is the implication? So let me show you this. Let me use this kettle for example. Now this kettle here is made up of metal. So if the operator, the user, touches the metal handle here, and then if there is leakage of current touching the body here, so the person will be electrocuted. So it's going to receive electrical shock. Okay, so if it does that, and the only way it will be protected is to allow the extra current to flow through this one, through the earth wire. So which is what? Yellow and green. So that is earth, and then so this is live, this is earth, and then this one is the neutral. Okay, in this wiring. So now, so appliance with what? An earth wire, so likely has a metal casing. So the metal case is a good conductor of electricity. If a fault occurs and a live wire come in contact with the metal casing, then the casing becomes dangerous, so it causes a shock. Okay, earth wire provide a safe path. So if instead of the person receiving this shock, so majority of the current I flow through this earth wire. Okay, the earth wire connects the metal casing to the ground. If a fault occurs, the current flow through the earth wire to the ground. Okay, tripping a fuse or circuit breaker and preventing electric shock. Okay, so this is just the mechanism, a safe mechanism to protect people that operate electrical appliances from being electrocuted. Okay, this is another technical question again. We'll look at AC generator. The magnet rotates about a fixed point round a fixed core. The electromotive force output is a sine wave. Okay, a series of crests and zero. Okay, the magnet is shown in 3 positions, P, Q, and R, during its rotation. So the magnetic field in the coil is 0 at Q. So here it is 0, and then but changing most rapidly. So if it's changing most rapidly, so at this point the wire is vertical. So let me show you the diagram. So let me show you the diagram of what is happening there. So this is exactly what is happening. So I got this from okay, save my exam. Okay, all right. Now, if the coil of wire, let me look at the rotation of the coil of the wire. Okay, first of all, let me show you the diagram for a AC generator. This is DC. This one, almost the same thing, but the only difference between AC generator and DC generator is that DC generator have a split ring, while AC generator have a slip ring. So that is a different, major difference here. So this is the coil of wire that is rotating inside the magnetic field. So then we have the carbon brush where the current is tapped to go and power the load. Okay, so let's see what happened during the rotation. So when the coil is vertical place and then the field passes through, it is 0. So the EMF is going to be 0. And then when it rotates and it comes to this point with, okay, a quarter of rotation, so, and then the coil is aligned with the field in the same plane. So we have the maximum cuts on the magnetic field. So we have the maximum EMF induced in the wire. And then when the rotation is vertical again, it comes to 0. And then, so you look at this one. So you have 0, maximum, 0. Then we have what minimum, then it comes here. So this is how the coil showing the rotation and then the induced EMF. So we can go and answer the question and use the idea to answer this question now. So we are looking at question number 31. So based on that, with the explanation I have given, so which one is the correct answer? So the correct answer here is A. Okay, the EMF at position Q is larger than that at P. Okay, so now let's look at question number 32. In question number 32, we are talking about the transformer. So a transformer. So for transformer, the power, so we have the primary power, which is the current primary multiplied by the voltage primary is equal to secondary current multiplied by the secondary voltage. So once we know that, and then they say that the power for the secondary coil, the light, is what? 12 watts. So we can now say, what is the current in the power supply? So we have 12 watts because they say it is 100%. So the total energy input in the primary coil is equal to the total power output in the secondary coil. So with that, we know that this one is equal to, so let's multiply. So you have 24 volts times I primary. So this one will become primary is equal to 12 watts divided by 24, which is equal to 0.5 ampere. So 0.5 ampere. So the answer is A. Okay. Now the scattering of particle by goal leaf. So Ernest Rutherford's experiment. So it's alpha particle that was scattered. Now we have this one here, representation of an atom. An atom is, you have the mass or nucleon number, then you have the proton number, then you have the atomic, the symbol of the atom. So we have this nucleus. So if this mass number is equal to number of proton plus number of neutron, while this one here is equal to the number of proton. So if we do this, so that will going to give us 17 plus 18 all over number of 7, so 17. So then x, so this will give us 35, 17, x. So the answer is D. Okay. Now, the dashed line on the graph shows the decay curve recorded from a sample of a particular radioactive acid. The count has a background radiation. And now, how do you get the background radiation? So you look at this. So with this, you can know the value of the background radiation. So which is where the thing ended here. So this is the BG. BG is 10. So if you want to correct, you have to track that 10 down. So here is just slightly above, below 60. So you can now come to this slightly above. This one is just 60. So here will be 50. And then here will be 10. Then here will be this. Here will be this. Here will be this. So if you do that, you can now track the correction part to correct for the background radiation. So the correct answer for number 35 is going to be, so the correct tracing is B. Okay. Now let's look at number 36. Which type of radioactive soil is suitable for use in measuring and controlling the thickness of paper? Okay, manufacturing factory. Okay. Now the half-life. So we're going to be looking at number 36 is going to be C, better, with long half-life that can penetrate. So you know that alpha is stopped by we have the different material that can stop this. So we have paper, then beta can travel through this, but it will be stopped by aluminum. So this one can be stopped by paper. And then you have gamma ray. Gamma ray can only be stopped by a brick wall or lead. So this is lead or brick. So these are the three radiation. So you look at the material that can stop each of them. Okay. So the one that can pass through, but it will be stopped by lead. So this is a paper, so you can use it to measure the thickness of the paper. So for number 36, the answer is C. We have done that. Then number 37. Okay, this graph shows the corrected count rate. So take note of this word here. So this one, the background radiation has been eliminated. So he started with what? What is the count rate at the beginning? 10,000. So the time it will take for it to decay to half of its mass, which is what, 500 half. So you trace this. Very good. So you trace this value here to the graph and then trace it down. So that will give us 2 minutes as the half-life. So now the Earth orbit the Sun. So if the Earth is orbiting the Sun, so we can talk about something like this. So the Earth orbits the Sun. Okay, all right. Oh, sorry. Okay. Okay, so we have, okay, and then on the orbit you have the Earth, then you have the Sun here. Okay, then you can now talk about the radius. Okay, and then if you want to find the speed, is equal to 2 pi r, then multiply by the time of oscillation. So v is equal to 2 pi times the radius, which is what, 1.5 times 10 raised to power 11 meter. Sorry. Okay, so divided by 365 days to turn around, so convert it to second, 365 days. So day times 24 hour times 60 minutes make 1 hour, 60, convert 60 minutes to second. So if you carry out that division, it's going to give, alright, so that is approximately 2.99 times 10 raised to power 4 meter per second. So it's approximately, so the answer is A, approximately 3. Then, so let's look at question number 9. Which statement about the life cycle of a star is correct? The correct answer is A. Now, a red giant forms a planetary nebula with a supernova at its center. No. A white dwarf star eventually forms a black hole. No. Then most stars expand and form a protostar. No. Protostar is the beginning of, it's not an expansion stage. This is the formation stage. Okay. So let's just see the reason why these other ones are not correct. So let's quickly look at this other reason here. Okay. Now, why the option B, C, and D are not correct. So you can just look at this detail here and then get a better understanding. So let's go to the last question. Okay, the last question here is question 40, the measuring of the speed of receding galaxy. All right, so we have a galaxy that is receding from the Earth. So we have that galaxy here. All right, so it's traveling with the speed of velocity v and is at a distance d from Earth. Okay. Okay, so here we have the planet Earth. Okay, so and then you have this galaxy here that is receding from it. So if we want to calculate this, we know that for you to be able to do this calculation, you know that v is equal to Hubble constant multiplied by the distance. So from the first part of the equation, we can calculate, we can get the Hubble constant, which is the velocity divided by the distance, so which is equal to, okay, velocity 7,000 kilometer per second divided by 3.1 times 10 raised to power 21 kilometer. So this will give us close to, what is the value now, 2.26 times 10 raised to power minus 18 per second. So with this, we can now calculate, let's calculate for the second part. What is the, so, and then, so Hubble constant, we have gotten that. So the Hubble constant is 2 raised to power minus 8, so which is what? Almost 2.3. So it's either A or B. This is not part of it. These two are wrong because we are looking for that. Then the other question now is, what did they say? Calculate using this data, what is the speed of the galaxy? What is the speed of a galaxy at a distance 6.2 times 10 raised to power 21 from the Earth? So we want to find V is equal to the Hubble constant we've calculated multiplied by the new distance given. So V is equal to 2.26 times 10 raised to power minus negative 18 multiplied by 6.2 times 10 raised to power 21. So this one will give us 14,000 kilometer per second. So 14,000 kilometer per second. So the correct answer is D. Oh, sorry, dear. Okay. So that is not the answer. 14,000. So because this one, the correct answer here is B. Because I told you earlier on that this 2 is wrong, So this is the correct answer. So with that, we come to the end of this, the review of the So we've come to the end of the review. So let's look at, so you can scan this and then just make a contact with me. And as you are preparing for the exam, I'm going to share a link here. So if you want me to prepare you for the exam, there's an opportunity for you to book for an online preparation classes. So I wish you good luck in the next exam. Just like and share the video. Okay, thumbs up.